Okay, welcome back. In example number 2, the first thing I'm going to do is to first express, I'll change all this base to a common base. Okay, and the common base that I think I should be using is 2. Okay, so for the first term over here, 4 can be expressed as 2 square, okay, to the power of x minus 1, multiplied by the square root of 8 is 2 to the power of 3, okay, this is to the power of y, and below 32 is 2 to the power of 5. Okay, so let me just slowly expand this out. So this, in order to expand this term, I will be using this law that you see over here. Okay, so this gives me 2x minus 2. Okay, and the square root sign over here, okay, can be changed to power half. Okay, so I mean, for those who are unsure, let me just give you a simple numerical example. So root 5, for example, can be written as root, or rather 5 to the power of half. Okay, so I'm changing the square root sign to power half. Okay, so in the numerator, I have 2 to the power of 3y. Okay, to get 3y, you will be applying this law that you see over here, and over 2 to the power of 5. Okay, I'm almost there, Okay. Okay, so at this point in time, the power half will go to both, okay, the numerator as well as the denominator. I'll be applying this law that you see over here. Okay, so 2 to the power of 3y over 2, 2 to the power of 5 over 2. Okay, and to combine all of these together at one go, take note that I have a common base, which is base 2, okay, and when performing division, okay, with a common base, the powers will subtract, okay, as you can see in this law over here. Okay, so at the same time, okay, let me just leave this as it is, and this is just 3 over 2y minus 5 over 2. Okay, and finally, I can subtract this power from this power over here. So let me just continue over here. So 2 to the power of 3 over 2y minus 5 over 2 minus 2x minus 2. Okay, why am I doing this? Because I have a common base. Okay, I have a common base, and when I'm performing my division, okay, the powers will subtract. Okay, so I'll get 2 to the power of 3 over 2y minus 2x, and negative 5 over 2 plus 2 will just give me minus half. Okay, so that's all for example number 2. Okay, let's move on to the toughest example of them all. This is example number 3, and what I'm going to do is to simplify some of these numbers that you see over here. Okay, so remember, I can only apply the laws of indices if I have a common base. So I'm going to change 25 to 5 square. And for those of you who are not familiar with this symbol, this dot that you see over here, it just means multiply. So for example, 2 dot 3 is just 2 times 3, which is just 6. Okay, so just a numerical example. Okay, so going back to the question, we have this, and then over here, okay, for 5 to the power of 2x plus 1, I shall factorize it to make it look like this. 5 to the power of 2x times 5, okay, to the power of 1, okay, which is redundant to write the 1. I'm just writing it to make it clearer to you. Okay, and 25 once again can be expressed as 5 square. And finally, 17, 5 power 2x. Okay, so far so good. What I'm going to do next in the numerator, I shall multiply these powers together using law number, okay, or rather this law that you see over here. So I have 5, 3x, 5, 2 minus 2x. Okay, and in the denominator, I'm going to factorize out my 5 power 2x. Okay, 5 power 2x. And by the way, 5 square power x is just 5 2x. Okay, so this term you see over here is 5 2x. Okay, so let me just factorize out 5 2x. Okay, so I'll have 5 plus 3 plus 17. Okay, and in the numerator, I'm going to do some further simplification. So now that we have a common base, the powers will add up because I'm doing a multiplication. So I'm using this law over here. Common base, multiplication, the powers add up. So 3x plus 2 minus 2x. Okay, over 5 power 2x. 5 plus 3 plus 17 is just 25. Okay, let me just continue over here. So in the numerator, I'll have x plus 2. Okay, in the denominator, I'll have 5, 2x. Okay, 25 is just 5 squared. Okay, let me further simplify this. So this is 5x plus 2. Okay, similarly, common base, the powers will add up, plus 2. Okay, and simplifying this further, now that I have a common base and I'm performing a division, the powers will subtract. Okay, and x minus 2x is just x, 2 minus 2 is gone. So 5 to the power of negative x, okay, is my final answer. Or if you want, you can write it as 1 over 5 to the power of x by applying this law that you see over here. Okay, so hope you enjoyed this video on certs, and I hope this example clarifies some problems that you have with certs. Just to summarize, okay, oh sorry, just for indices rather. Okay, just to summarize, okay, the laws of indices are as such. There are in fact 9 of them. Make sure you have them written down because it's very important that you are familiar with these laws before we can proceed on to more difficult examples. Okay, let me just leave you with some practice questions before I end off. You can pause the video here to copy them down. Okay, I'll see you in the next video.